This is the Boston VR regular monthly meetup. Our speaker is Sanjit Singh, and he will be presenting his project on navigation, AR for navigation for astronauts. Take it away.
Sure. All right. First of all, can everyone see?
Yes.
Just confirm with me and then I'll start. All right. So as Jeff mentioned, I'm doing a NASA Suits competition. Suits stands for Space User Interface Technology Challenge for students. So the topic here is going to be design thinking for head-mounted display, designing for lunar missions. And my team is, of course, Team ARISTOBULE. That's the team name we picked out. And yeah, so I'll start talking about the application of augmented reality for space exploration. So this is my whole team here. I'm the project lead for NASA Suits, where we're representing Rutgers University, and I'm running different team members from different backgrounds. Dr. Mridul Anjaneya is the faculty supervisor for the NASA Suits project, along with assistant professor of computer science at Rutgers University. So this is the whole background. So space exploration ranges from navigation, geology sampling, and extravehicular activities, or EVA for short term. So the task of the astronaut is, of course, for outside the spacecraft are to do this activity called extravehicular, or EVA. So basically EVA involves like repairs, could involve doing other work with satellite systems or lunar modules. So one of the important components around extravehicular is monitoring the astronauts' vitals. So there's a lot of things when it comes to lunar missions. So one of the things I'm going to talk about is when it comes to EVA tools and geology sampling and collecting samples when navigating on the moon. So there are several useful tools out there, but one experimental tool that NASA still hasn't worked with is augmented reality, specifically HoloLens 2. This is stuff that's experimental, and they want head-mounted display systems that can help astronauts as they're going on the moon. So the question is, how do we help astronauts on lunar exploration? Well, to break down the concept, so the challenge goal is to design head-mounted display software to be used to explore the surface on the moon and hopefully other planetary bodies such as Mars. So actually, NASA's basically short-term goal is they want to first get more astronauts on the moon and master moon exploration, because eventually, I'm sure we're familiar with Elon Musk's mission to Mars by 2030. So they eventually, as they have more understanding about terrestrial body on the moon, eventually then they want to use the same procedure through this challenge and get more people on mission to Mars. So some of the stuff that the head-mounted display should be useful for and be able to do for astronauts is protect the astronaut from hazards of EVA. It must be flexible enough for the astronaut to collect geological samples and operate a variety of tools. Furthermore, the software must be comprehensive enough to be serviced simply and quickly. So as mentioned, the goal overall is augmented reality displays to help astronauts during Artemis mission on the moon. So some of these core objectives include navigation, extravehicular activities, and vitals, which would be telemetry streaming. So telemetry streaming is basically conditions of the suit, which would also monitor the astronauts' vitals, such as heart rate, oxygen level, blood pressure, battery level, and more. So this is a challenge with the core objectives. So basically, as mentioned, the four major core components will be auxiliary conditions, navigation, EVA system state, and geology sampling. So here I will break down the concept more. So navigation. Navigation involves not as EVA, so that involves like, EVA activities, excavation sites, and other points of interest. And EVA, basically, that's connected to telemetry streaming because a lot of that involves monitoring the astronaut's vitals during space. Geological sampling is basically having a visual documentation to help the astronaut on what type of samples they're to collect when they're on the moon. Could be rock samples or any general samples of what they usually would collect when they're on the moon. And generally, astronauts have ideas of what they're collecting because they're scientists themselves. So basically, the visual display is just to give them more ideas and be able to help them keep track of stuff visually at the same time they're on exploration. And then auxiliary conditions would involve lighting conditions, control methods, and system tutorial. So basically assisting the astronaut on task or have more brighter light as they're exploring on the moon, because in space, it's very, very dark. So this is some of the approach NASA has done before touching augmented reality. So one of the tools they use is a lunar roving vehicle, LRV, which is used as transportation on the surface of the moon during Apollo program. So far, it transported 2 astronauts in exploration to the moon during Apollo 15, 16, and 17. So some of the components the rover carried were tools, and these are scientific tools and equipments and used for communication gears and collects lunar samples. So this was also be able to be remote controlled by the astronauts. So overall, the lunar roving vehicle, it was designed for operating up to 78 hours during the lunar day. In addition, it is able to make exploration up to a distance of 40 miles, but some of the restrictions that it has is being within a certain range of 6 miles from lunar modules. So that's one of the big restrictions they have. So if astronauts out of range and this is more, more farther, it's basically that's where the restriction is. So now this is the solution. Through Microsoft HoloLens 2 device, it can hopefully give astronauts more ideas about how to do stuff at the same time visual display systems. So they can, some of the features, as I mentioned, navigation is setting up waypoints from one location to another in order to accurately plan out trajectories. So let's say you're trying to get from location A to location B to location C. Through the HoloLens 2 device, you have a way to plan out waypointing for like different navigational areas. So that's one of the things HoloLens can be able to help for, kind of like a GPS, except through a headset device. In addition, astronauts will also have a way to monitor vital signs and suit conditions in real time. So that's where the whole telemetry streaming comes in, and also provide warning signals when necessary. So like, let's say in space, and this is data that NASA has provided us, like for example, in space, astronauts' heart rate should be between 80 to 100 BPM. If it goes out of range, if you look at the picture all the way to the right, where it says suit condition warning, it'll have some like biometric UI warning saying warning, suit condition, or heart condition, or whatever. Any general telemetry warning will pop up, which will alert the astronaut that they need to like get back in the ship, recharge their suit, or whatever. Basically, that's what it's going to do. In addition, geology sampling, that's another core tool as mentioned to explore on the moon. With the use of our UI control systems, astronauts can toggle different UI samples of what they were to collect on the moon. So that's one of the core useful things. As you look at the image all the way at the left, in between, if you look at the image next to the biometric warning, another integrated feature we have is note taking. So as the astronaut absorbs what they see on the moon or any certain things about samples they collect, they can be able to record all that through a UI note-taking feature. So here I will show you a little basic demo. This is actually the very first demo I had when I was start playing with HoloLens. So it may not be something too crazy, but it was a start. So as you see, I'm using gesture recognition on the UI. So one of the other core components I actually was using is voice recognition. So let's say voice command, if the astronaut doesn't feel like using their hand gestures or typing so much, or using clicks, they could use voice command to kind of like tell through the headset to tell like what they want to see or what type of UI they want to use. So yeah, as you see, this is a little bit, I was like, actually, this is when I was still actually, still getting used to HoloLens. So this is, I'm trying to like pretend I'm on the moon and I'm collecting samples. So this is one of the note-taking features I was working with. Yeah, I was actually trying to type on here. I'll actually a little bit skip more. That's just me interacting with the UI, nothing too crazy. So yeah, this is actually some of the geology sampling UI. So as the astronaut was to collect information, they can kind of use the documentation to have an idea more about this samples they were to collect. So here you can see kind of brief information about some of the sampling tasks they would do when it comes to geological samples. Yeah, Jarvis is basically the AI voice command I'm using, kind of like from Iron Man, because I was like, why not? All right, so go to the next slide. So now that you saw a simple demo, this is kind of there's the need versus the want. So the need is, of course, we still want to finish up the telemetry streaming data for vitals and parse it into UI displays. So that's where NASA actually provides us whole JSON data, which we're integrating into Unity, and then basically parsing all this data in real time. Polishing up the navigation component will also be nice. So one of the actual challenges of HoloLens is trying to accurately plan out wayfinding algorithms. So like there are some SDKs, but they're still not mature yet with HoloLens. Most of those SDKs work with mobile. One of the ones that I'm currently using is ARWay. They're still experimenting with HoloLens, but that's one of the things that my team and I are hoping to discover more, is if we can use some SDKs or just write some of our own wayfinding code from scratch. Improving some of the UI designs, because some of the UIs, as cool and nice looking as they were, I feel some of the interaction and some of the other stuff still needs a little bit more mock-ups. Finishing up EVA assistant tool through HoloLens. So that's only going to be happening once we get the telemetry working, because there is a direct connection between them. Getting photo capture and recording feature to work. So that'd be actually something really, really great, because think about it, is if you're navigating on space, you can be able to record through HoloLens in real time and stream it back to ground station, which can also help people on ground station kind of guide the astronaut where they're going and like what they're collecting. And I feel it's like a more like virtual collaboration from like Earth to space. Lighting effects, so basically figuring out some good auxiliary condition and lighting, which one of them involves lighting effects through HoloLens. That would be some really unique feature we would like to get done. And then I guess modifying a checklist for keeping track of tasks to complete when on lunar mission, because mission to the moon, there's so many tasks you got to complete. And I think, helping the astronaut like through a display system, like saying, okay, these are tasks you need to do. Once you complete them, check them off. So it's like, it's more a way to help them stay on task. The want. So computer vision API for object recognition. So the want is actually the long term, actually. So computer vision API for object recognition to help the astronauts accurately recognize objects they collect in space. So I guess like basically you can use computer vision to detect what objects are in space that give astronauts accurately idea, okay, these are the labels of geological samples we're to collect, or these are the right samples. So to computer vision object recognition, we can train some data and be able to like through HoloLens kind of process all that information to be able to recognize what objects in space are being detected. That'd be on the moon, of course. Improve and have fully working waypoint navigation system also through SLAM algorithms. So kind of like reconstructing once we have waypointing working and like as we navigate, we can also try to kind of have like SLAM algorithm to kind of 3D reconstruct the whole environment, which can also show to like which that data would get transmitted back to ground station to kind of show, okay, this is a whole 3D, this is the whole environment I have in 3D around me in space. If this is the right location, or if this is the location I'm supposed to be, or this is where you expect me to collect samples from, that's where ground station can provide feedback if this is the right place or not. Another thing is, of course, integrating holoportation feature, which was done by Microsoft research team, which demonstrated a real-time 3D construction of an entire space, including people, furniture, object, using a new set of depth cameras. So like basically like two people are wearing HoloLens and they have like depth sensing cameras around them, which would basically transmit each other into like holographic virtual images of themselves. It's kind of like what you might see in Star Wars or Star Trek, literally the future. So that type of research we actually hope to integrate long-term into our work. Artificial bot for guidance. So basically AI bot for like basically something like a physical Jarvis, like you see in Iron Man movie. We would like to get like a smart AI system that could be more like a navigation, can help guide the astronaut, help in terms of navigation, or say, like, let's say if the astronaut was to plan out trajectory, then the AI would say, all right, this is the number, this is the distance from trajectory A to B to C, etc. So we want an AI, like an AI bot for not only trajectories, but also monitoring vitals in real time and keeping track of all that instead of having the human worry about all that issue. And then this is the overall summary. So as mentioned, by 2024, NASA hopes to advance human autonomy, enabling technologies necessary for elevated demands of lunar surface exploration and extreme terrestrial environments. They want to have more better developed user interface systems through head-mounted display, which could be through an augmented reality or mixed reality device to help assist crew members with EVA responsibilities and tasks during a lunar mission and EVA system state information in a very non-obtrusive way. In addition, having visual display systems have astronauts improve and innovate optical solutions with emerged technology, making the future of EVA missions more effective and efficient would be important, because think about it. Instead of having the astronaut put on the HoloLens we'll look at it like this. Once the astronaut put on the HoloLens, you don't want them to wear a spacesuit on top of the HoloLens, because that's like too much. It's going to burn their eyes out. So what NASA is trying to integrate is whatever display system you have in the HoloLens, they want to get these optical displays through the spacesuit helmet. So basically through the helmet, kind of like what you've, I'm sure if you've seen Iron Man, it's basically very similar logic to that. And then overall, NASA hopes to use the same concept procedure once we master more exploration to the moon and have more idea about the terrestrial environment, is to do eventually the same thing to mission to Mars. So there's a big mission going on and a huge collaboration between NASA and SpaceX. So I would like to give acknowledgement out here to the NASA Suits team for selecting my team and I, to Dr. Jing Wang, who's a professor of physics at Mercer County Community College in West Windsor, New Jersey, and also my leadership coach, to Dr. Miguel Antonea for agreeing to be a faculty supervisor for this project, to Array of Stars. They're a startup actually based in Toronto, who actually agreed to sponsor my project and send us the HoloLens too. Otherwise, we would have actually had to write up a full grant proposal just to get a HoloLens. So they really saved us time and helped us out. And they have also been collaborating with us and giving us also feedback in terms of augmented reality displays. To Kelly Mann, NASA mentor engineer on the Jarvis team. So Kelly is he's basically our assigned mentor who's been giving very good feedback, and if this type of displays will be useful for astronauts in space or not. And then to Professor Matthew Stone, who's the head of the computer science department, who wrote an acknowledgement letter to the NASA Suits team on selecting my team and I. So these are some of my references. And this is a survey. Jeff, I'll actually send you the link if you want. It's just for feedback of what you liked about it. What do you think could have been better, or what more would you like to learn?
Cool.
And
can you put that in the chat?
I can. And yeah, thank you all for listening.
Super. Thank you, Sanjit. I'll do my F4 clap for you. That's really interesting. Questions?
I'll go first.
Yeah.
Yes.
One thing I've heard a lot is how like every moment of an astronaut's day is kind of determined by someone on Earth, kind of telling them what to do. And that's good and bad, obviously. But I think sometimes that communication can be a bit frustrating because the people on Earth can't really see very well what the astronaut's doing all the time and understand where they're at. And the people on Earth may need to explain some concept to the astronaut to help them through some instructions or something. And it seems like augmented reality could really help in this area. Have you thought about that?
Yeah, and actually that's the whole point of holoportation, because people on Earth can't see what the astronauts are doing in space, so that's the whole reason of holoportation.
Cool.
Very nice. One thing you might do is list out more. Sorry. I saw it throughout your talk, a collaboration between what the humans are good at and what the computer is good at, and how they work together. For example, in the visual recognition, right? humans are going to be better than computers for a really long time in putting it all together, but computer vision can pick out things and package it for the user. So it'll be very interesting to see how this develops. So.
Thank you.
Do you think your approach could be used on Earth somewhere, perhaps by archaeologists?
Perhaps, maybe. We actually haven't thought of that, but it's a possibility. We definitely would consider it. If it works well for space, and might as well do it on Earth as well.
Yeah, you could certainly test it here. Yeah, go out into the desert. Yeah. How about the training process? You know, how long would it take to learn to use your system?
So that's a good question. That really depends on the astronauts, and that's why NASA does human-in-the-loop testing for astronauts to kind of train their astronauts to learn them. Like, you know, astronauts themselves are scientists, but they may not know all the latest stuff going on. So, like, that's the whole point of human-in-the-loop testing. NASA puts their astronauts in situations that, you know, they have simulation training as they were already on the moon, utilizing all these resources. So they have a whole procedure just for that.
Cool. All right. Any other questions? There was discussion in the previous talk about headsets being right for different people. I guess your astronaut helmet is going to have to work for all sizes and shapes of heads and faces. Yeah.
So actually, when it comes to the helmet, a lot of the display is going to be in the helmet. So when it comes to the whole helmet and suit design, that's a lot of stuff that NASA's already actually worked on and built. A lot of the telemetry hardware components are already built in the suit. It just needs to communicate to the display.
That's great. Is a little bit like the Army's integrated HoloLenses for their soldiers.
Basically, I think except NASA's trying to do it without even relying on a headset. It's like I said, it's more like the Iron Man.
Well, they already have a headset, right? All they need to do is add the AR.
It seems it might be most similar to the F-35 fighter, which has a very advanced augmented reality display built in. But it kind of begs the question, it's not really clear to what extent the pilot can still fly the plane without the helmet. And one early criticism of the system was like if a pilot drops the helmet, which I think costs several $100,000 or so, on the way out to fly the plane, can he or she still fly the plane? And that's another interesting aspect to this, because like, what happens if you're on the moon and it's not working?
Right.
Yeah. Interesting.
Then again, I'd be lost without my phone just about anywhere. So.
Right. Excellent. Well, Sanjit, could you put your contact information in the chat?
Sure, my email or my LinkedIn or both?
Both, whatever you like, yeah.
Sure, I'll do that right now. I'm just pasting my link.
Yeah. Yeah, this has been, I think, the 154th BostonVR monthly or BostonVR meeting. They're more than just monthly. And thank you, Sanjit, for being our second speaker tonight.
Thank you.
Yeah, I think what I'll do is make 2 recordings from tonight. one focused on your talk and the other on Karen's. So, and then I will post both links on the event page, and I will give them to the iLearn people, and hopefully, I know they'll post Karen's talk. Maybe they'll post yours as well, and it'll be on our YouTube channel. This is great. Thank you for contributing.
Thank you so much, Jeff.
Yeah, good talk.
Thank you.
The work shows. All right.
Thank you, Sanjit. Good night.
Yeah,
Night.
good night.
Cheers.
Take care.